Hello everyone. Now, after studying the symbols for the different operations that are performed under determinants, let us now discuss what are the properties of determinants. The properties that we are going to discuss today holds true for second order determinants as well as the third order determinants. So, let's get started. The first property of determinants that we are going to study today, or else the first theorem of determinants that we are going to study today, is states that if all the rows of the determinants are converted into the corresponding columns, the value of the determinants remains same. That is, if we perform an operation where we change all the rows of the determinant into the columns of the determinant and vice versa, then the value of that determinant will be equal to the value of the new obtained determinant. Let us prove this one. Let us take an example where let us say a determinant having a value of this one 2 1 minus 1 3 4 2 5 minus 3 4. Now if we take this determinant and if we perform an operation of this one, then the value of the new determinant that we get must be equal to the original value. So let us first find the original value for this determinant, which will be equal to what? You do 2 times 4 times 4 minus of minus 3 times 2 minus 1, which is this one, times 3 times 4 minus 5 times 2, which is this and this, minus this and this, minus of 1, which is this, times 3 times minus 3 minus of 5 times 4. How we did it? We considered this times this minus this times this, and this is basically a plus of minus 1. Now the value of this one will be equal to 2 times what is this, 16 plus of 6 minus 1 times 3 12 minus 10 minus 1 times minus 9 minus 20. What we get over here, 2 times 22 minus 1 times 2 minus 1 times minus 29. So at the end when you calculate this value, we get it equal to 44 minus 2 plus 29, which is equals to what? 71. Right, so our original determinant has a value of 71. Now let us perform an operation Ri to Ci. So our determinant D will become what? All the rows of the determinant will be converted into columns. So what are the rows of determinant? 2 1 minus 1. So we write it at like that row will become a column. Second row, that is 3 4 2, will become a second column, and third row will become what? The third column. Now let us find the value for this determinant as well and see whether the value of this determinant is equals to this one or not. Now value of this determinant will be equal to what? 2 times 4 times 4 minus of minus 3 times 2, right? Minus 3 times 1 times 4 minus of minus 1 minus 3 plus of 5, which is the third element of the first row, times 1 times 2 minus of minus 1 times 4, which gives us what? 16 plus 6 minus 3 4 minus of 4 3 plus 5 2 plus of 4. which gives us 2 times 18 minus 3 times 1 plus 5 times 6. Now, which is equals to 2 times 22 minus 3 times 1 plus 5 times 6, which gives us what? 44 minus 3 plus 30, which will eventually get the value of the dash as 71. So the value of determinant, original determinant D, and value of that determinant after interchanging the row and column, we get that same value, right? So we can say that D is equals to D dash if we perform this operation where we are interchanging all the rows to the column of the given determinant. This is the first theorem, or else we can say the first property of the determinant. Now let us go to the second property of the determinants. The second property, or the second theorem of determinant, states that if two rows or if two columns of determinant are interchanged, the value of the new determinant is the additive inverse of the value of the given determinant, which means that is, if we perform an operation where we interchange the two rows, or if we perform an operation where we interchange the two columns of a given determinant, then the value of a new determinant will be equal to the negative value of the original determinant. Now let's prove this with the same examples that we did earlier, where we consider determinant 2 1 minus 1 3 4 2 5 minus 3 4. The value for this original determinant was equal to what? 71, right? Now let us perform an operation. Let's perform an operation C23 on this original determinant. So when we perform this C23 operation on our original determinant, the new determinant that we get can be given by this value. Over here, if we are performing this operation, this means that we are interchanging column 2 and column 3 of this given determinant, meaning that we are interchanging all the elements of column 2 with all the elements of column 3. So our column 1 will remain as it is, right? Our column 2 will become our column 3, and column 3 will become our column 2. Now let us find the value of this one, and let us see whether it is equals to the negative value of our original determinant, which is 71. Now let us solve the value for this determinant, which is given by 2 times 2 minus 3 minus of 4 times 4, which is this one, right? Minus of minus 1 times 3 times minus 3 minus of 5 times 4 plus of 1 3 times 4 minus of 5 times 2, right? So we get 2 times minus 6 minus 16 plus 1 minus 9 minus 20 plus 1 12 minus 10. So what is the value that we are getting? 2 times minus 22 minus 29 plus 2, which is minus 44 minus 29 plus 2, which will eventually get us what value? Negative of 71. Our original determinant has the value of 71. So we can say that if we perform an operation where we interchange two rows or two columns of a given determinant, then the value of that determinant, of the obtained determinant, will be equal to the negative value of your original determinant. This is the second property of the determinant. Now let us move towards the third property of determinant. Now, the third properties of determinant, or the third theorem of determinant, states that the value of the determinant gets multiplied by k if every element in any of its row or column is multiplied by k, where k is a real number but without the zero value. Okay, that is, if we perform an operation of where we multiply the value k, which is a real number but not zero, with all the elements of a respective row or respective column of a given determinant, then the value of the new determinant that you get will be equal to the k times the value of your original determinant. Now let us prove this theorem by the same examples that we have did earlier. In our previous example, we considered this determinant where the values of determinant are 2 1 minus 1, 3 4 2, 5 minus 3 4. The value of this determinant that we got earlier was 71. Now let us prove this theorem, or else let us prove this property of a determinant. Now let us perform an operation C1 of 3. What does it mean? We are going to multiply the value 3 with the column 1 of our original determinant, right? So our new determinant becomes what? It will be equal to, what is our column 1, which is this one. We multiply column 1 with 3, so we get 2 times 3 is 6, 3 times 3 is 9, 5 times 3 is 15, and rest of the value remains the same. Now if we solve this determinant, what we get? 6 times 4 times 4 minus of minus 3 times 2, right? Next value, minus of 1 times 9 times 4 minus 15 times 2, which is this times this minus this times this, plus the third element of the first row, which is minus 1 times 9 times minus 3 minus of 15 times 4, right? The value that we get is 6 times 4 4 is 16 plus 6 minus 1, 36 minus 30 minus 1, 27 minus 60. So the value that you get over here is 6 times 22 minus 6 minus 1 times minus 87, which gives us 132 minus 6 minus plus 87, right? Which gives us 213. Now our original determinant value was what? 71. And according to our third property, your new determinant will be equal to k times d. We performed an operation C13 where the value of k was equals to 3, right? So d dash should be equal to what? 3 times 71, which is 213, which is our value that we got over here, right? Thus we proved the third property of the determinant. Now let's move towards the fourth property of the determinant. The fourth property of determinant states that if the corresponding entries or the elements in any two rows or columns are identical, then the value of the determinant is 0. That is, the value that you get for that determinant will be equal to 0. Now let us prove with an example. Let us take the determinant value 2 1 1, 1 2 2, 3 1 1. Now as you can see in this determinant, the column 2 and the column 3 are identical, meaning that all the elements in both the columns are identical. Then if all the elements of these two columns are identical, then the value of that determinant must be equal to 0 according to our fourth property. So let us find out what is the value of this determinant. It can be given by 2 times this minus this, which is 2 minus 2, minus of 1, which is our second element of first row, times 1 times 1 minus 3 times 2, right, plus 1 1 times 1 is 1, minus 3 times 2. What are the values that you get? 0, minus 1, 1 minus 6, plus 1, 1 minus 6, which will be equal to 0, plus 5 minus 5 will be equal to 0. Thus, we proved the fourth property of the determinant. Now let's move towards the fifth property of determinant. Now the fifth property of determinant states that the value of the determinant does not change if any of its rows or columns is multiplied by a non-zero real number, let us say k, and added to another row. That is to say that if we perform an operation R of ijk, where k does not equal to 0 and I is not equal to j on a particular given determinant, then the value that we obtain of the new determinant will be equal to the original determinant only. Now, this operation means that we are going to multiply the value k with the ith row, and then we are going to add that ith row to the jth row of the given determinant. Now let's prove whether this fifth property of the determinant holds true or not. Let us take the original determinant that we have earlier took, which was 2 1 minus 1 3 4 2 5 minus 3 4. The value for this determinant that we got earlier was what? 71. Now let us perform an operation. Let us take r to 1 on r to 1 of 2, which means that we are going to multiply value 2 with the second row of the given determinant, and then we are going to add that second row to the first row, right? Okay. When we multiply 2 with the element of the second row, the second element of the second row becomes what? It's this. It becomes 6, 8 and 4, right? And then we are going to add all of this element into the elements of R1. So let us do that. Our new determinant that we obtained after performing this operation will be what? We are adding all this value to the first row. So 6 plus 2 will be 8. 8 plus 1 is 9. And minus 1 plus 4 is 3. All the rest of the elements of the original determinant remains the same, which is 3 4 2 5 minus 3 and 4. Now if we solve this one, what we get? 8 times 4 for 16 minus of minus 3 times 2, right? This times this, minus 9, that is the second element of first row, times 3 times 4 minus of 5 times 2, which is this times this minus this times this, right? Plus 3 times minus 3 minus of 5 times 4. What we get? 8 times 16 plus 6 minus 9 times 12 minus 10 plus 3 times minus 9 minus 20, which we get it as 8 times 22 minus 9 times 2 plus 3 times minus 29, which gives us what? 8 times 22 is 132, right? Minus 9 times 2 is 18, right? And 29 times 3 is 87, but with a negative sign. So when we add all of this, or else when we subtract this 2 from this one, what we get? Yeah, we get 71 only, which is the value of our original determinant, remember, which is 71, right? So we can say that the value of the new determinant doesn't change if we perform this operation, or else if we perform this thing. on the given determinant. Okay, the last property that we are going to discuss today is the sixth property of the determinant. The sixth property of determinant states that you can basically add two determinants if both of the determinants have two identical rows or columns. That is to say, in this determinant and in this determinant, the second row and the third row are identical. Then at that time, if you want to add these two determinant, the value of that determinant will be given as like this. So you just add the first row and rest of the identical rows remains the same. Now let us prove this sixth property of determinant by an example. Let us take an example, this one. This is our first determinant, this is our second determinant, and this is our final determinant that we get. Now according to the sixth property of determinant, what it says, if two determinant has two identical rows or two identical columns, then at that time you can simply add that determinant to form a final determinant where you just add the unidentical row or column to get your final value. So based on the sixth property, you should get the value of determinant as 1 plus 2, which is this, 1 plus 1, which is this, and 2 plus 4, which is this one. And rest of the elements that are identical in second row and third row of the determinant 1 and 2 will remain the same as well in the final determinant. Now in order to prove this, let us say that this determinant 1 and 2 is our left hand side and determinant D is our right hand side, right? So if we can somehow prove left hand side is equals to the right hand side of our equation, then we can say that the sixth property holds true for any kind of this numerical, right? So let us do that. For determinant D1, the value of determinant D1 will be given by what? 1 times 1 minus 6 minus 1 times 2 minus 3 plus 2 times 4 minus 1, right? Determinant 2, the value of determinant 2 will be given by what? 2 times 1 minus 6 minus 1 times 2 minus 3 plus 4 times 4 minus 1, right? So D1 will be equal to what? Minus 5 plus 1 plus 6, right? Determinant 2, the value of determinant 2 will be what? This one will be minus 10, this one will be 1, and this one will be 12, right? So if we add D1 and D2, what we get? Minus 5 plus 1 plus 6 minus 10 plus 1 plus 12, right? So what we get? 5 for D1 plus D2, right? Now coming back to our D, what is the value of D? Which is 3 2 6 2 1 3 1 2 1. Now if we solve this one, we get 3 times 1 minus 6 minus 2 times 2 minus 3 plus 6 times 4 minus 1, which gets us the value 3 times minus 5 minus 2 minus 1 plus 6 times 3, which gives us minus 15 plus 2 plus 18, which is equals to 5. So our D1 plus D2 gives what? D1 plus D2 is 5, as well as our D is equals to 5. So our left hand side is equals to right hand side of our equation. So can we say that this property holds true for two determinants having two identical rows or column? Good. So these are all the six properties of determinants that we have discussed today. Let us revise them quickly. So what are the properties that we have discussed so far? This one. In first property that we have discussed, we have studied that if we interchange all the rows and with all the columns of a given determinant, then the value that you get for the new determinant will be same as the value of your original determinant, right? In the second property, we studied that if we interchange any two rows, or if we interchange any two columns of a given determinant, then the value of the new determinant that you obtain will be equal to the negative value of your original determinant, right? in the third in the third property, we discussed that if we multiply any non-zero real number in with any ith row or with any ith column of a determinant, then the value that you get of the new determinant will be basically a product of the non-zero real number times the original value of your determinant, right? In the fourth property, we discussed that if the corresponding elements in any two rows or columns are identical, then the values of the determinant is 0, right? In the fifth property, we discussed that if we multiply any non-zero real number with an ith row or ith column, and then add that ith row to the jth row or to the jth column, then the value of the new determinant that we get will be the same as the value of your original determinant, right? And then at last we proved that if we want to add two different determinant which has two identical rows or two identical columns compared to each other, then at that time you can simply add the non-identical row or non-identical column and form a new determinant, keeping all the identical rows or identical columns as it is, and you get the value of that determinant, which is equals to the summation of d1 plus d2 will be equal to your d. Good. These are all the six properties that we have discussed today. I hope you all understood what are the different properties of a given determinant. In the next lecture, we are going to discuss about the minors and cofactors. Thank you very much for staying and listening to my lecture. If you have any doubts related to this or any other topic, then please feel free to ask us in the comment section below, or you can email us on our your queries on our email ID oatsinstitute at gmail.com. If you did like our effort, then please don't forget to hit the like and subscribe button below and share our lecture with your colleagues and friends. Thank you. See you all in the next lecture. Till then, have a nice day. Bye bye.